So here what you see on this slide are the payoffs for the call and put options at expiration, right? So this is something that we actually already covered through our examples previously. This is just sort of formalizing this little bit with some notation and stuff like that, right? So don't get confused with notation and stuff here. It's more important for you to make sure you understand how the payoffs work. Just to go through this and relating this to examples we worked on before. Payoff to call holder or call buyer, right? So if you buy the call option, what is your payoff at expiration? So remember, these are all payoffs at expiration, meaning that the assumption is you buy the option and you hold on to it right till expiration. And at that time, what is your payoff? Again, remember, this is payoff, and then profit is when you subtract the premium, right? So what is the payoff for call holder at expiration? ST is the stock price at expiration. X is the exercise price. So ST minus X if ST is greater than X. Again, let me show you the example that we worked on for the call option. This was case one, right? Stock price at expiration. So now we are calling that ST. It is 175. Exercise price is 160, right? So again, call buyer has the right to buy at 160 and then can sell the share at 175. What is the payoff? The difference between these two, right? ST minus X. So anytime ST is greater than X, the payoff would be ST minus X. Again, remember, this is not profit. The premium is not subtracted here. This is just the payoff. So ST minus X, right? This is $15. So we have already done this calculation before. What if the stock price is below 160 or 160 or lower? Well, then the option would not be exercised and the payoff would be 0. So when ST is greater than X, it's ST minus X. When ST is less than or equal to X, it is 0. And that is essentially what you see over here. ST minus X if ST is greater than X, 0 if ST is less than or equal to X. That is for the call buyer. Now, one thing that is also important is that you can take the other side of this trade as well. So you can be a buyer of the call option, but you can also sell the call option. So you can be a seller or what is known as the call writer. All right. So think of this as a transaction between two parties. I mean, that's the easiest way to think about how these payoffs work for the writer. These are two parties entering into transaction. One is selling the option, that is the call writer, and the other party is buying the option, that is the call holder or call buyer. So we already covered the payoffs for the call buyer or holder, right? ST minus X if ST is greater than X and so on. What about call writer? Well, call writer is just taking the other side of this transaction. So the payoff for the call writer would exactly be exactly the opposite of that of the buyer. All you need to do is put a minus sign in front of buyer's payoffs to get the writer's payoff. So if buyer has a payoff of $15, writer would have a payoff of minus 15. Okay, now buyer pays the premium, right? Buyer pays the premium to buy the option. Who does the premium go to? The premium goes to the writer or seller. So writer actually collects the premium. So that is what why the writer is actually doing this for the premium. Okay, so writer actually collects the premium. So anytime you have to compute the payoff or the profit for the writer, again remember this is for the buyer, right? Similarly for the put option, this is for the buyer. Anytime you have to compute it for the writer, all you do is take this number, put a minus sign in front of them. If buyer's payoff is $15, writer's payoff would be minus 15. If buyer's profit is $10, writer's profit would be minus 10. If buyer's profit is minus 5, meaning buyer is losing money, then the writer is making that same amount of money. Writer is just taking the other side of this trade. So whatever is buyer's gain is writer's loss, and vice versa. And the same idea applies to put option as well. Okay, so so it's always best to actually work out the writer's payoff by thinking from the buyer's perspective, because the option to exercise or not exercise lies with the buyer, right? If buyer exercises and makes a profit, then the writer loses. If buyer loses, then the writer actually gains. Okay, so if you want to sort of look at this complete example, in this case our premium was $9.15, right? So premium was $9.15. So the net profit, this is again the same example that we worked on before. Net profit here is 15 minus $9.15. So this is 585. Again, this is for the buyer. Okay, so in this trade, buyer has a net profit of $5.85. That means the writer has a net loss of $5.85. Again, just put the minus sign in front of those. Now, if the stock price is say 155 here, the buyer has the right to buy at 160. So the buyer would not exercise the option. What would be the buyer's payoff in that case? Well, ST is less than X, so buyer's payoff would be 0, and the buyer loses the entire premium, right? $9.15. So that is our case 2 that we discussed previously for the call option buyer. So buyer's loss of $9.15. So that would be writer's gain of $9.15. So that is the best case scenario for the writer. Okay. Remember we said previously the maximum possible loss for the buyer is the premium, and therefore the maximum possible gain for the writer is the premium. Got it? So writers are actually doing this for this premium. They will collect this premium and they hope to keep all of it, right? So that's the best case scenario if they are able to keep all of it. Same thing with the put option. So again, for the put buyer, this is our example, right, that we worked on. This is the favorable case. Put buyer has the right to sell at 160, and if the stock price is say 155, so you can think of this transaction as buying at 155, selling at 160. What's the difference? Difference is $5. That is the writer's payoff. And again, if we bring in the premium from that example, premium is $2.62, right? So the net profit for the buyer is the payoff minus the premium, right? So that is 232, right? Oh, sorry, 268 here. Okay, so 232, 260. Okay. So that is the put buyer's net profit from this position, and therefore for the writer it would be a loss of 232. Again, just like the call option, the put buyer has the worst case scenario where the buyer loses the entire premium, and that would be the best case scenario for the writer. And that would happen when, in case of put option, that would happen when the stock price is 160 or higher at expiration, right? So again, buyer's payoff is X minus ST if X is greater than ST. Otherwise, the buyer's payoff is 0 if X is less than ST, because at that point the buyer is not going to exercise the put option, right? If ST is less than X, the option is exercised. If X is less than ST, then the option is not exercised and the payoff is 0, and that would be loss of the premium. So that is what you're seeing over here. If ST is greater than or equal to X, the option is not exercised, the payoff is 0. If st is less than or equal to, or if st is less than x, like in this case, st is less than x, the payoff for the put holder is x minus st, right? So again, don't get confused with all this notation and stuff. Just make sure you're able to do the payoffs. And again, just want to emphasize this one more time. For the writer of both the call and the put option, the way to approach that is to think about buyer, right? What would be the buyer's payoff? What would be the buyer's profit? And just put a minus sign in front of that and you get the writer's payoff and writer's profit. Compute the buyer's payoff and put a minus sign. Compute the buyer's profit, put a minus sign there, and you get the writer's payoffs and profits. Okay. So next I'm going to show you a few graphs, payoff diagrams. So this is the payoff for the call buyer, right? This is the payoff diagram for the call buyer. So in this case, we have this call option with exercise price of 80. Let me write that down actually. Okay, so exercise price is 80 and premium is $14. All right, this is for this example that you're looking at here. This is the payoff for the call buyer, right? Call holder. So on the x-axis you have the stock price at expiration, and on the y-axis you have the payoff and the profit. So this solid line is for the payoff and the dotted line is for the profit. Again, remember, payoff for the buyer can never be negative, right? Because if it is not favorable, the buyer does not exercise the option. So payoff for the buyer can never be negative. So since the exercise price is 80, at any price 80 or lower, right, this option is not going to be exercised by the buyer. Remember, buyer has the right to buy the stock at 80, right? That's the exercise price. So if the price is lower, the buyer would not choose to pay that higher price of 80. The option is not going to be exercised. So at all prices 80 and lower, the payoff would be 0. And when the price is at expiration, again remember this is at expiration, and the price is say 81, the payoff would be $1. The price is 82, the payoff would be $2, right? 82 minus 80 and so on, right? So beyond 80, then it just increases dollar for dollar with increase in the stock price. Okay, and then how do we come? So this is the payoff. How do we compute the net profit? If take the payoff, subtract the premiums. In this case, again, the premium is $14. So whatever is the payoff, from that you subtract the premium. So again, if the stock price ends up at 80 or lower, the payoff is 0. All the premium is lost, right? So the net gain would be minus 14, right? And then beyond 80, as the stock price goes up, the option would be exercised, and buyer starts to recover some of that premium. What is the break-even point here? What is this point here? This point here would be 94. When the stock price at expiration is 94, what's the payoff? Payoff would be $14, right? 94 minus 80, ST minus X for the call holder. So 94 minus 80, that would be $14. So buyer's payoff would be $14 and buyer paid $14 to buy this option. So the net gain would be 0, right? So 94 is the break-even point, and the buyer starts to make a positive profit beyond stock price of 94, right? And then this can just keep going higher. Again, as we said before, the maximum possible gain is unlimited because there is no upper bound on the stock price. The maximum possible loss is just the premium, right? So this is for the call buyer or call holder. For the writer, as we have said before, it's just the opposite, right? So if you were to draw the payoff diagram for the writer, it would be a mirror image of this, right? Just flip it across this on this ST, get the mirror image, and that would be the writer's payoff. So this is the writer's payoff, right? For that same option, exercise price of 80 and premium of $14. So again, 18 and lower, the option is not exercised. Buyer's payoff is zero, writer's payoff is zero. Buyer loses $14 in premium, so writer gets to keep $14 in premium. This is the best case scenario for the writer. Maximum possible gain for writer is the premium. Beyond $80 stock price, the writer's profit starts to go down. 94 is again the break even. Above 94, buyer makes money and writer loses equivalent amount, right? So it's again just the mirror image of what we saw earlier. And because the maximum possible gain for the buyer is unlimited, the maximum possible loss for the writer is unlimited. Remember, writer is losing money as the stock price is going higher, and the higher the stock price goes, the more money the writer loses, right? Beyond 80. So and again, there is potential for huge losses in call writing. Therefore, call writing is extremely risky by itself. Writing a call option is very dangerous. In fact, most brokerages will probably not even allow you to write the call option by itself, right? Because if the stock price, let's say, all of a sudden has a big jump, as a writer, you might end up losing a lot of money. Okay, so straight call writing is extremely risky and perhaps will not be allowed by your brokerage. Okay, and then what about the put option then? So here is the payoff for the put option. In this example, let me see. In this example, again, the exercise price is 80. The premium is not specified here actually on this graph. Let's say the premium is $4, right? So I'm going to assume a premium of $4 for the sake of discussion. This is for the put holder, right, or put buyer. So put buyer has the right to sell at 80. Right to sell at 80 is valuable if you can buy at a lower price and then sell at 80, right? If the price is more than 80 though at expiration, then this option is worthless for the buyer, right? So at 80 and above, this option is not exercised and the payoff is zero. Writer has a loss of a $4 premium, right? Below 80, at 79, the payoff is $1, right? X minus ST, right? So X is 80 here. If ST is say 79, then 80 minus 79. So buyer buys the stock at 79, sells at 80, $1 payoff. At 78, the payoff is $2. At 77, the payoff is $3, and so on, right? So below 80, as the price declines, the payoff increases. What about the profit? So profit also starts to go up above 80. Break even here would be 76, right? So the premium is $4. So break even stock price would be 76. When the stock price is 76, 80 minus 76, so $4 would be the payoff. $4 is the premium, so that's the break even point. So this point right here uh, uh, is 76, and the put buyer actually has a positive payoff when the price is below 76, right? And the lower it goes, the higher is the payoff. For the writer, I don't have the graph here on the slide for the writer, but again, it would be just the mirror image, right? So just flip it across, flip it around on this ST, and you will get it. Buyer's gain is writer's loss, and vice versa, right? So it would be the mirror image of this graph right here. So that is the payoff for the put buyer and the put writer. Okay. All right. So on this, in this next discussion, I'm not going to actually go over the details of these calculations here, but this is just in your textbook. They are showing that options by itself can be quite risky. We kind of already learned that, but they can be combined with other strategies, or you can have like a small position in option to for the potential of upside while keeping your downside limited and so on. So basically this is a discussion where you're comparing three possible strategies. One is 100% in stocks, other one is 100% in options, and this third one is a conservative type of a strategy where most of your money is in the safe asset, right? Bulk of your investment is in treasury bills, and you're putting little bit of money in options just for that potential of upside. So I'm going to skip over these calculations. They're not very difficult actually. If you want to go over this material and try to understand this just for the sake of further learning, you can actually do that. But really the key idea here is that you see how risky the options are, but how useful they can be as a part of your portfolio as well. So you see this all options strategy, there is a range of prices here where your return is minus 100%, right, when the option is not exercised. But once you start making money, it actually increases quite rapidly, right? This is a pretty steep line here. So that is how it works for options. We already know that. For stocks, it's of course a straight line. You buy at 90, for example. If it goes lower, you lose money. If it goes higher, you make money. So that's pretty straightforward. And this third strategy is where most of your money is in treasury bills and little bit of exposure to options. So you have some downside here if your option position does not work out, but then you're capturing all the upside of the options as well. So you can use options in combination with other assets in your portfolio is basically what the bottom line here is, in addition to highlighting the riskiness of options. So next what we are going to talk about is some popular option strategy.